Hello students, welcome to Jagannath Mathematics Tutorials. This will be our lecture number 4 on the topic relations. Today we are going to learn the inverse of a relation. Let A and B be two non-empty sets and let R be a relation from A to B. Means R is a subset of A cross B. Then the inverse of R denoted by R inverse is a relation from B to A. If R is a relation from A to B, then R inverse is a relation from B to A. Suppose R contains, suppose this is set A and this is set B, and R is a relation from set A to set B. Suppose this is set A and this is set B. Now let's say 1 maps to C, 2 maps to A and 3 maps to B, right? Then R is of the form 1 comma C, 2 comma A and 3 comma B. Suppose we want to find R inverse. How to find R inverse? By this definition, R inverse will be from the set B to A. Set B contains the elements ABC and set A contains the elements 1, 2 and 3. Now this 2 maps to A over R, so this A will map to 2 in R inverse. This 3 maps to B in R, so B will map to 3 in R inverse. Similarly 1 maps to C in R, so C will map to 1 in R inverse. Therefore, we can write R inverse is a relation from set B to A defined by R inverse equals to this A maps to 2, so A comma 2, this B maps to 3, B comma 3, and this C maps to 1, C comma 1. Right, so we can clearly see that if R is a relation from set A to set B, then R inverse is a relation from set B to set A. Similarly, you may observe this that R contains the elements of the form of the ordered pair 1 comma C, 2 comma A and 3 comma B. But here in case of R inverse, this contains A comma 2, B comma 3 and C comma 1, and this is a subset of B cross A, right? As R was the subset of A cross B, so R inverse is a subset of B cross A. So if R contains the ordered pair of the form AB, then R inverse contains the ordered pair of the form BA, right? Also, you may see here that the domain of R is what? Domain of R is set A here, and the range of R is set B. From here you can check, but the domain of R inverse is this set B, and the range of R inverse is this set A. So here comes the important relation that the domain of R is equal to range of R inverse. As you may see, domain of R is A, range of R inverse is A. So this is equal to range of R inverse. Similarly, you can also see that a range of R is equal to domain of R inverse, which is equal to set A. So the range of R is equal to domain of R inverse. This concept of the inverse will be more clearer if you see these two examples which are over here. First example, let A be the set containing 3 elements 1, 2 and 3, and B be the set containing 4 elements A, B, C and D. Let R be a relation from A to B defined by this. Then find R inverse. See, R is a relation from A to B, so R inverse will be a relation from B to A. So R inverse is what? You see this first element as A comma 1 here. In case of R inverse, it will be A comma 1. Here this is 1 comma C. So in R inverse, this is C comma 1. Similarly, 2 comma D becomes D comma 2 and 2 comma C becomes C comma 2. I hope this example is clear to all of you. Next, define a relation R on the set N of natural numbers by R contains all those ordered pair x, y such that y equals to x plus y and x is less than 4. Now we all know that the set of natural numbers is 1, 2, 3, 4, 5, 6 and so on. Now x belongs to natural number and x is less than 4, means x belongs to the set 1, 2 and 3. It cannot be 4, right? So we need to find this relation first to find R inverse. First we will find R, then we will find R inverse. Now see, R is of the form this, and we need to satisfy this two conditions as well. So x takes values from 1, 2 and 3, y equals to x plus 5. So put x equals to 1, we get a y equals to x plus 5. Here x is 1, so a 1 plus 5 is 6. So we get first ordered pair as 1, 6. Similarly, put x equals to 2, you get a y equals to 2 plus 5 by this equals to 7. So we get 2 comma 7 as second ordered pair. Similarly, put x equals to 3, you will get 8, right? So basically you get this R, right? Now we will find R inverse. Now how to find R inverse? Now R inverse, just interchange the position of the ordered pair. Means 1, 6 will become 6, 1, 2, 7 will become 7, 2, 3, 8 will become 8, 3. That's it. I hope this is clear to all of you. Now we will see some more questions. Let A be the set of first 5 natural numbers. Means A is of the form set of first 5 natural numbers, means 1, 2, 3, 4 and 5, and let R be the relation defined on set A. So R is defined on set A. Now what does this means? means R is a subset of A cross A, means R goes from this set A to set A itself. This is the meaning, right? Means R is a relation from A set to A, right? And here A contains first 5 natural numbers, right? Now we are asked to express R and R inverse as the set of ordered pairs, right? So R is defined as xy such that x is less than equals to y, right? So R is of the form xy. See, we define a relation R from A to A. So is 1 less than equals to 1? Is 1 less than equals to 1? See, 1 is equal to 1, so this condition will hold. So we get first pair as 1 1. Is 1 less than equals to 2? Obviously yes, as 1 is less than 2. So this pair will also come. Similarly 1 3, 1 4, 1 5 will also come, right? Then means this will map with every element from here. 1 maps. Similarly, can 2 comma 1 be the pair? No. Why? As 2 is not less than equal to 1. So 2 comma 1 will not form a pair with 1. But 2 comma 2 will form a pair. 2 comma 2 why? As 2 is less than equals to 2. As 2 is equal to 2, so this condition will hold, right? Similarly, you may check for 2 comma 3. This will also come as 2 is less than 3. Similarly 2 comma 4, 2 comma 5. Now next, for 3 comma 1, does 3 comma 1 will belong to R? No. Why? As 3 is not less than or equal to 1. So this pair will not belong. Similarly 3 comma 2 does not belong to R, right? So we will start here from 3 comma 3 itself. 3 comma 3, 3 comma 4, 3 comma 5. Similarly, for the case of 4, 4 comma 1 will not belong to R. 4 comma 2 will not belong to R. Similarly 4 comma 3 will not belong to R, right? As this condition fails, so but 4 4 will belong to R, right? So here this will be 4 comma 4 and 4 comma 5. This is basically our R. I hope this thing is clear to all of you, right? Now we have find out R. Now can we find out R inverse? Yes. How? Just interchange these positions. Just interchange this position. 1 comma 1 remains the same as you may interchange, but if you interchange these two positions, this becomes 2 comma 1. If you interchange these two positions, this becomes 3 comma 1, 4 comma 1, 5 comma 1. Similarly, you can see over here, I have interchanged these two. You can interchange these two. 4 comma 2, 5 comma 2, 3 comma 3, 4 comma 3, 5 comma 3, 4 comma 4 as clear to all of you, then please like the video if it is clear to all of you. Right? So we have find out the R inverse. Now can you tell me what will be the domain of R? Can you tell me? Domain of R is the set of all first components. See, one here, two here, 1 2 3 4, right? So domain of R is what? 1 2 3 and 4. This is the domain of R, which is a subset of set A. Similarly, you may find the range of R. Comment below the range of R. Similarly, you can also find the domain of R inverse. Domain of R inverse is a set of first elements 1, 2, 3, 4, 5, which is clearly set A, and you can find the range of R inverse as the set of all second components. This 1, 2, 3, 4. 1, 2, 3, 4, which is a subset of R. Now you can recall that to find the range of R, we know what? The range of R is the domain of R inverse. So the domain of R inverse is A set here. Therefore, the range of R is set A. Means you can check from here also. 1, 2, 3, 4, 5. Range is 1, 2, 3, 4, 5. Right? That's it for today's lecture. Thank you to all.